Welcome to this video. Today we are going to compare the design process of ASICs and FPGAs. We can divide the design process into two main categories, front end and back end. Front end starts with design specification, where we define the system requirement and specification, usually in high-level block diagrams, and everything is documented. This document can be used later by design engineers as a reference. Next is RTL modeling. In RTL modeling, we use hardware description languages like SystemVerilog to model or design. The next step is functional simulation. At this step, we want to verify the functionality of our design, and we don't care about the timing delay and potential timing violation. We only want to make sure that our design behaves as expected. The next step is synthesis. Synthesis transforms our RTL design into netlist of logic gates based on technology library and user constraints. Floor planning in ASIC involves defining the shape and size of the chip. We also define the optimal position for functional block, I/O pad placement, and macros such as memory and analog circuits. Power distribution planning is also in this step. In FPGA flow, the similar step is mapping. Mapping involves assigning functions into configurable logic block within the FPGA. These include implementing the combinational logic using the lookup tables, sequential logic using registers, and memory using block RAM resources available within the FPGA. After floor planning, the standard cells that implement logic are placed within defined areas on the chip. For FPGAs, the corresponding step is also called placement. This involves determining the physical location of the mapped logic blocks on the FPGA. The next step, common to both ASIC and FPGA, is routing. Routing involves connecting logic gate and macros using different metal layers available on the chip or FPGA interconnect structure. Static timing analysis or STA is then performed. This process checks the timing of digital circuit without doing the SPICE simulation. It uses timing information extracted from a standard cell library and parasitic information derived from wire load model and physical libraries to identify potential timing violation. Following the static timing analysis, we usually perform gate level simulation. This involves simulating the design at gate level using synthesized netlist and timing information to further verify the functionality of design after the synthesis process. For the ASIC, the last step is 𝗙𝗂𝘂 tapeout. 𝗙𝗂𝘂 is a standard file that represents the physical layout of the chip. This file is sent to the foundry for the manufacturing of the actual chip. The final stage for the FPGA is program the FPGA. At this stage, a bit string file is generated. The bit string file contains configuration information that defines how logic block and interconnect within the FPGA should be programmed to implement or design circuit. This bit string file is then loaded onto the FPGA. Logic equivalence check or LEC is a formal verification technique used to mathematically determine if two different representations of digital logic are functionally equivalent. For example, the RTL code and the synthesized gate level netlist are the same.